Hello and welcome to today's video. In today's video, we are going to discuss what we call coordination complexes or coordination compounds. Okay, so what are coordination complexes? So we say these are compounds made up of a central metal atom or ion that is datively bonded to a ligand. I'm going to underline those key terms and then give more description about what those particular terms mean. So these are compounds made up of a central metal, which can be a metal or an ion, that is datively bonded to a ligand to form a complex, to form what is known as a complex. So allow me to give more context about what this particular description or definition means. So what this simply means is that we have a metal, which can be a metal atom or can be a metal ion, that is datively bonded. So datively bonded is also known as coordinate bonding. So what is this type of bonding? So coordinate bonding is where we have a donor. So in this case, we are looking at a ligand. So a ligand acts as a donor of a pair of electrons. So what happens in dative bonding is that both pair of electrons will come from a ligand. So in this case, we can have a ligand here with a pair of electrons, can have another ligand there with a pair of electrons. So a metal just presents an empty orbital that is ready to receive the electrons. So both or all the electrons come from a ligand. So in dative bonding, we have a metal ion that is bonded to a ligand, and what is existing, the type of bond that is existing here, is known as a coordinate or dative bond. So this is a bond where a pair of electrons come from a ligand and then they are donated to a metal ion. So in coordination complexes, we will see this type of bonding where both electrons will be donated by a ligand to a metal, and then they form what we call a complex. Now, I would like us to understand a few terminologies as we look at coordination complexes. So I will just say important terms. So we're going to encounter these terms which are quite important. So the first one is known as a central metal, ion, or atom. A central metal, ion, or atom. So what is important about this is that usually this is a transition metal. So when we're looking at coordination complexes, usually we use what we call a transition metal that is datively, I've explained dative bonding, datively bonded to a ligand. So like I mentioned, we're going to have a metal that is bonded to a ligand. And remember, a pair of electrons will be donated by a ligand. In other books, they describe a ligand as a Lewis base because it donates electrons. If you go back to acid base acid base theory. So in this case, we're trying to understand what a central atom is. So a central atom is usually a transition metal. For example, we can say cobalt in, let's say we have a complex of this, so hexamine cobalt 3. So in this case, we are saying cobalt is representing a metal ion or a central metal ion. So we have a cobalt that is at the center, then it's bonded to 6 of those um, 6 of those amine compounds. So basically that is, so yeah, something like that. Now, to understand more, I'm just trying to give a geometrical representation of what this appears, or something similar to this. So at the center we have central atom. So there's need for us to understand what they mean when they say a central metal ion or central atom. Then the other term that we also need to understand is a ligand or ligands. So what is a ligand? So these are ions or molecules that donate. So these donate a pair or pairs of electrons to the metal ion. They form what I have explained. They form a dative bond with a metal atom. And then later on, we'll look at the types of ligands and how we classify them. 3, I would like us to understand the term coordination number. What do they mean when they say coordination number? So coordination number basically talks about uh, the number of ligands, the number of ligand donor atoms. So the number of ligand donor atoms that are directly bonded to the central metal ion. Just to give an example, so you can say 6 in, for example, we have this complex so this is called hexacyanoferrate 3. So here we are looking at these number of ligands. So there are 6. So we have F, and then there are 6 of cyano that are directly bonded to the metal. So that is the coordination number. It tells us the number of ligands that are directly bonded to the metal. Then 4, the other term, important term that I would like us to know, is known as the coordination sphere. So what do they mean when they say coordination sphere? So this implies the central metal ion and its directly attached ligands. Usually they are shown in square brackets. So what does this mean? So for example, we have this complex. So anything that is put in square brackets is referred to as a coordination square. So this is called hexa aqua chromium 3. So anything that is put in square brackets is referred to as coordination sphere. Then the opposite of this is known as counter ion. So these are ions outside the coordination sphere. The ions that are outside the coordination sphere, that balances. So the job is balances the charge of the complex. For example, if we have a chloride in a complex of hexaamine cobalt 3 chloride. So this guy out here is what is referred to as a counter ion. So its job is to balance the charges. So if this is positively charged, then that should be negatively charged to balance the charges in the complex. Now, after having knowledge about these 4 important terms that I have described, now we can go in depth to try and understand the types of ligands. So remember, in summary, a ligand is just an electron donor. So they donate a pair of electrons to a metal ion, and this is done through ductive bonding. So the first type of a ligand, the first type is known as a monodentate. A monodentate ligand. So what do they mean when they say a monodentate? So by monodentate, it means that there is only one number of donor atom or atoms. So there's only one number of donor in these particular compounds. We can give examples. So examples are in water. So in water, when we look at it from a structural perspective, so there's only one donor, which is oxygen. So oxygen donates the electron. If we look at NH2, this is NH3, this is, so it appears like this, and then we have a pair of electron there. So it's the nitrogen in this case that happens to be a donor. I can give an example of a chloride. So it's only chlorine, a cyano. It's only that. So there's only one donor. There's only one number of donor in this monodentate ligand. The second type is referred to as a bidentate ligand. So obviously bi, we know that bi means two. So in this case, we are looking at two number of donors, two number of donors. The common examples are oxalate. So oxalate is C2O4 2 negative. So when you look at it from a structural perspective, it looks like this. So there's a pair of electrons here, those that can be donated. So there are two pairs that can be donated. The other example here is known as ethylene diamine. So ethylene diamine, we are looking at, in terms of structure, we are looking at something like this. So pairs like this, nitrogen. Then we have a pair of electrons there, and a pair of electrons. So these two can be donated. So this can donate a pair of two electrons. So ethylene diamine is an example of a bidentate. Then oxalate is also an example of a bidentate. Then the third one is known as a polydentate. So this means more than two donor atoms The common example is the common example under this is ethylene diamine tetraacetate, which is usually known as EDTA. When we look at the structure of this, it's a bit complex, but very simple. So appears something like this, bonded to this, no, bonded to nitrogen, and there's a CH2 here, there's a CH2 there, CH2 here, CH2, then you have an active there, similar thing here. Yeah, so in terms of the pair of electrons, we're looking at there's a pair here, 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 there's a pair. So this does 6 pairs of electrons will be bonded to a metal ion. So EDTA is a very common example of a polydentate ligand, and we'll be able to see it in most of the complexes that we'll look at as examples. Then the last one, which is the fourth one, they are known as ambidentate ligands. So for ambidentate ligands, usually it's about which atom is bonded directly to a metal ion. So we can say they bond through two different atoms. I'll be able to give an example. For example, if we're looking at NO2 negative. So when this one is bonded through nitrogen, it's known as nitro. So it's bonded through nitrogen. But when it's bonded through oxygen, it changes the name to nitrito. So nitrito means it's bonded through oxygen. The other example is thio SCNL. So this, when bonded through sulfur, it's called thiocyanato. So thiocyanato, it means it's bonded through sulfur. But when it's bonded through nitrogen, the name changes to isothiocyanato. So it means it's bonded through nitrogen. So those are the 4 types of ligands that we are going to encounter in coordination complexes. Then, lastly, I would like us to look at the types of coordination compounds or complexes. The types of coordination complexes. So the first type is known as cationic or cationic complex. So when they say you have a cationic complex, it means that the complex is positively charged. So the complex is found on the positive side. For example, I'm gonna use red for complex. So we have hexaamine cobalt 3, then allow me to use Cl3. So this is a positive side. So when the complex is found on the positive side, this is called a cationic complex. Then the opposite of that obviously is anionic complex. So by anionic we mean our complex is negatively charged. Negatively charged. For example, you have sodium 4K. So cyano, this is hexacyano ferret. So this is found on the negative side. Remember, in this case, the sodium is on the positive side. So when the complex is on the negative side, this is called anionic complex. Then the third one is just a neutral complex. So in a neutral complex, the complex is neutral. The complex is neutral. I'll give an example of carbonyl, tetracarbonyl, nickel 4. So this is a neutral complex. Then obviously we have the last one, which is not very common. It's known as a double salt. So in a double salt, we just have when this is dissolved, it breaks into ions. So for example, if we have this SO4 6H2. So this is quite not common, but the common ones are the neutral complexes, the anionic complexes, and the cationic complexes. So in the next video, we are going to look at the nomenclature of coordination complexes. How do we name coordination complexes? See you in the next video.